LOD2 – Creating Knowledge out of Interlinked Data. Welcome to the LOD2 webinar series, Linked Open Data Tools and Services for Publishers, Enterprises and Governmental Institutions. LOD2 is a large-scale integrating project co-funded by the European Commission within the FP7 Information and Communication Technologies Work Programme. This 4-year project comprises leading linked open data technology researchers, companies and service providers. Coming from across 12 countries, the partners are coordinated by the Agile Knowledge Engineering and Semantic Web Research Group at the University of Leipzig, Germany. LOD2 will integrate and syndicate linked data with existing large-scale applications. The project shows the benefits in the scenarios of media and publishing, corporate data intranets and e-government. Once per month, the LOD2 webinar series offer a free webinar about tools and services along the linked open data lifecycle. Stay with us and learn more about acquisition, editing, composing, connected applications, and finally, publishing linked open data.
Hi, thanks Martin, and welcome everybody to this presentation on the new Virtuoso 7 release enabling massively scalable big data analytics and RDF SQL data management. This presentation will be split into two parts, a brief company and Virtuoso overview by myself, and then the main part of the presentation will be on Virtuoso 7 by Ori Erling, who is the Virtuoso Program Manager. Opening Software is a long-established data integration and virtualization and storage middleware vendor. Our main products are our universal data access drivers for ODBC, JDBC and ADO.NET, as well as the Virtuoso Universal Server, which is the main subject of this presentation for the new release. In terms of products and services, we provide full range of support for consultancy, custom development to our customers in both open source and commercial formats. Some of our many customers are listed on this slide. Most of these are mainly Virtuoso customers. We have offices, or our main offices are in the US and in the UK. So moving on quickly to the Virtuoso overview. We are all seeking to solve the problem of data growing exponentially in terms of velocity, volume, variety, which Virtuoso helps in providing a solution for. Virtuoso provides an enterprise solution in any of the application domains indicated in this diagram. The product architecture diagram shows the various ways that data, ranging from relational to web accessible structured data sources, can be ingested into the Virtuoso storage engine and exposed via any of the many client interfaces supported. The Virtuoso Sponger middleware can be used for transforming structured and unstructured data sources to RDF as indicated in the diagram. Virtuoso also includes a content or web crawler that can be used in conjunction with the Sponger to perform scheduled ingestion of data into Virtuoso. Virtuoso is used for hosting many of the core data sets in the linked open data cloud, some of which, or the most popular ones, are listed on this slide. Virtuoso provides powerful standard support through its support for SQL, enabling traditional desktop client applications like Access, etc., to query RDF data in the Triple Store, as can any other ODBC, JDBC, ADO.NET, or other client application. This also enables integration with rich client applications using our WebDB ODBC bridge, for data access. The built-in faceted browsing service enables the search and discovery of data stored in the Quad Store. The Microsoft Silverlight HTML-based pivot viewer provides a front-end visualization of for both Sparkle and Sparkle-fed accessible data sources. Virtuoso has a built-in Sparkle endpoint for querying and sharing results. A visual query builder is also available. How do I get going? Simply download, install, and experience the power out of the box. And one final point is that Virtuoso will also be integrated into the next release of the LOD2 stack. So that concludes the brief introduction, and I will now hand over to Ori Erling to commence the main presentation of Virtuoso 7.
Yeah. Hi everybody. I'm Ori Erling, program manager for Virtuoso with OpenLink Software, and I'll be telling you about lots of exciting things to do with Virtuoso Column Store. Okay, like Hugh already said, the challenges are evident. Everybody's got lots of data. The data is not getting smaller. The data is more heterogeneous as it is more and more often integrated from more and more sources. Sometimes it is very large in volume. Very often it is the more data you have, the dirtier it gets, the more heterogeneous it is. And this presents a whole row of challenges, and to be able to deal with this complicated and rapidly changing situation, you need to have flexibility for data. This flexibility, on one hand, is a performance game, because if it takes too long to load data or queries run too slowly, your agility in analyzing the data is compromised. On the other hand, there is the question of variety. So if you must always, create the schema for the universe, a centralized, centrally managed data warehouse schema into which you must integrate the often unforeseen data that you might come across, you have a problem. This is why enterprises, and as well as the research world, have, certainly the big web players too, all have found the need for a schema last. So key value stores have become popular due to this. And RDF is certainly something that supports schema last or flexible schema. And when talking to customers, we very often hear that the motivation for people going to RDF has to do with flexibility of schema. So the world is increasingly agreeing on the importance of a flexible schema, but of course this importance cannot come at a prohibitive price in performance. And this is the thing that we set out to address and rectify with Virtuoso 7 Column Store. Inference is another thing that is often valuable. Again, certainly if you integrate data, you want to align schemas on the go, and inference can serve for that, but also it must have the right feature mix, and often it will need features other than those that are in OWL form, providing you the expressive power that you need to do this on-the-go data integration. And data integration is, of course, on the go all the time, because nobody does data integration for its own sake. It is done only in response to a need, and these needs are evolving. Okay, so then the question is really the price differential between the technologies like RDF that can give you the flexibility, and then the traditional, let's say, SQL database that is generally believed to be faster, but then where the flexibility is lower. And we wish to, next slide, the mission statement. It is our agenda to remove many of the obstacles that have traditionally hampered take-up and utilization of RDF and other related technologies, namely performance, scalability, price, security, and we have seen in many benchmarks, for example, SQL might run 10 times faster than the corresponding RDF, and we wish to bring this differential down to as small a factor as possible. We recognize that quite often if you have a physically application-tailored schema, things will go a bit faster than with a schema-last model, but we really wish to bring down the comparative cost of schema flexibility to a manageable level. Also scalability, I mean, how large can data get? With the column store technology, we get dramatic improvements in space efficiency, so much more data in a lot less space. And of course, the scalability, how big can data be in absolute terms? Okay, there's really no limit because you can go scale out. So there is flexibility in there also. I'll be talking about these things in more detail in the coming slides. So next one. So it is commonly believed that nobody can have an open Sparkle endpoint in a high-volume system, and this is a statement that we'd like to contest because, okay, we've been running DBpedia, for example, getting millions of hits a day for a long, long time, and there are techniques which will allow sustained operation also under peak loads. For example, we have anytime queries so that while you can query whatever you want, you will only get so much execution time for the query, and if the query then runs out of time, you will get a partial result. This is one thing. The other thing is fine-grained security model, whereby you can, especially if you are integrating public data and private data, you can grant differential access to different players. So the server has built-in web ID, and this web ID authentication can drive graph-level security so that once you have authenticated, you will see the data that you're allowed to see. So typically this involves some public data that's for everybody plus selected data sets for specific users, and there is graph-level security that can make sure that you only see what you're allowed to see. Same thing for writing. There is graph-level security for that too, so you can also have read-write endpoints. Okay, so next. Okay, so the column store. Okay, we are mostly known as an RDF vendor, but we have for all of time. I mean, we've been in the business much before there was RDF. So we have for all of time also had SQL support and continue to have this. So in one box you get full SQL 92, 99 functionality and RDF, and you can in fact mix and match Sparkle and SQL. Most people do not do this, but this is definitely a possibility. And okay, so we have revolutionized really the database engine by introducing two things: the column-wise compression, and this column store meme, which is certainly a central ingredient in today's analytics-oriented databases, and vectored execution, which often goes with column store technology. So as to specifically speed up large queries, and of course RDF is about large and unpredictable queries. We have had scale-out capability for a long time, so Virtuoso 6 also had a cluster capability, but with 7, these cluster capabilities much improved, significantly more parallel, significantly more scalable, and more manageable because of now being elastic, so that one can, with reasonable flexibility, increase the size of a cluster or shrink it so as to adapt to utilization patterns and so on, especially if you set out to do flexible data integration, if you set out to integrate all data that comes your way, you might not know at the outset how big your data set is going to be, and that's why you need to be able to flexibly grow the scale-out deployment. And this we can now do in a manner that's much more flexible than we used to be available. Also, stored procedures. We have always been very strong on stored procedures, and now we offer, especially for scale-out cases, new control structures for a distributed parallel execution. So one can, in fact, do parallel update-intensive workloads. For example, we recently did graph analytics, which involve running about synchronous process, which updates a lot of data all the time. And this can, in fact, be done also in a database setting, so without having to go to a graph analytics framework. I'll say a few words about that later. Okay. Then also we have now in open source, we have a full text index, which we've had forever, and geospatial index, which supports, which has an R tree, and it supports the OGC data types, so polygons, polylines, what have you, the standard data types. And of course, we have SQLMM-like query capability for these, so geosparkle compatibility is coming shortly. And right now we have a geospatial capability that's very much like geosparkle, but not exactly identical. Okay, next. Okay, so let's talk about storage. The idea of the column store is that typically it's been everybody's assumption since the beginning of time that a relational database has tables, and tables have rows, and rows have columns, and rows will be stored consecutively. So when you read the table, you will read all the rows, and within each row you'll have the columns in consecutive places. And this, on the surface of things, makes sense because, okay, if you expect to always update every column at the same time and always access every column of the row, this would be intuitive. However, especially with analytics workloads, we find that most queries do not touch all columns, and we find further that compression can be done much better if data is stored column-wise. That is, given a table, you take all the values in the first column and put them consecutively, I mean physically consecutive places. Then you take all the values of the second column, and again you put them in physically consecutive places, and so forth. And this has the effect that you will have data items that have similar values. They certainly have the same data type, but they also might have, let's say, a low cardinality column like an enumeration, let's say a country or a flag or something like that. Does not need a lot of bits because it will have very few distinct values, so you can compress them. Also, if you're talking about ascending values, let's say you have a key in an index, you will have values in order. So if it's a numerical value that's ordered, you can use deltas or delta encoding bitmaps. You can use run lengths if a value repeats. And all these techniques combine to give you very often, let's say, at least 3 times better compression than the best compression you can get in a row store. This is really our experience. And also in Virtuoso 6, which is a row store, we have, for that domain, very good key compression. So if we are talking about RDF storage, let's say Virtuoso 6 stores 3 times more data in the same space as it would do without any compression. So row-wise compression is 3 times better than no compression at all. Column-wise compression is 3 times better than row-wise compression, so making it 9 times or 10 times better than no compression at all. And this is what we hear in the marketing material of lots of other column stores. Vertica, for example, has been promoting this. So this means that, okay, for SQL workloads, it's safe to say, okay, for TPCH, for example, to have your data in memory with a column store, you need 1/3 of the memory or 1/4 of the memory that you would need with a row store. And this, of course, memory being a major cost factor in information systems is a very important thing. Okay, so then all the data types. When we went to RDF from SQL, we of course saw the necessity of implementing the RDF specific types, let's say URIs and RDF literals, all that in the engine, and of course these are natively supported as distinct data types. It is commonly thought in the BI world, in the business intelligence world, that column stores are good only for big queries. So you have a very fast scanning of big volumes of data, but your random access lookup performance suffers, or random insert likewise. This is not exactly true. We can also do very efficient random access with a column-wise structure. And this is something that is discussed, for example, in last year's March data engineering bulletin talks quite a bit about that. So you can go have a look at that if you're interested. So finally, some figures about space efficiency. If you take DBpedia, which is a very common, well-known RDF dataset, you used to get about 30 bytes per quad with Virtuoso 6. Now it's down to 9 bytes per quad with a column store technique with Virtuoso 7. Then you had for LOD cache, which is arbitrary web crawls, which have lots of tiny graphs, and some datasets are very regular, such as Uniprot, but then you have such datasets like social graph crawls and stuff like that, which are very irregular. Even there you get, let's say, 14 bytes a quad, as opposed to maybe 36 bytes a quad, as it was with Virtuoso 6. So that's still a very significant improvement. If you have a very regular datasets, like the benchmark datasets for TTCH or translated to RDF or the Berlin Sparkle benchmark, then of course everything is lots smaller, again 6 bytes a quad. So that LUBM, well, is maybe 5, but it's so unrealistically regular, that's not interesting. Okay. Okay, so let's talk about execution. Okay, what's vectored execution? This is a technique wherein you run any operation in a database engine, whether it's querying, index lookup, insertion, update, what have you. You always run it on a large vector of values. Okay, so of course one effect of running on a block of values always is to minimize the interpretation overhead. You need to decide what operation you are doing only once, and then you do it for 10,000 values or 1,000,000 values, so the time to decide the operation and to get to the right code is essentially eliminated. Also, you can do CPU-friendly algorithms, meaning that when you're doing the same operation on a lot of data, there's ready possibilities for parallelizing this. In certain cases, you get instruction level parallelism, because if you have, let's say, lookups, you will have locality. If you sort your incoming data, then a random sequence of lookups becomes an ordered sequence of lookups. And of course, if you do ordered memory access, then you automatically get cache prefetching and such features from modern CPUs. And also, you can program your database engine with tight loops that take advantage of suprascalar execution, out-of-order execution, and all of this. So vectored execution is a very good fit for modern hardware. And this is something that, for example, the people at CWI with whom we have been working in this project have extensively demonstrated in MonetDB and later VectorWise. Furthermore, especially when we have heterogeneous data, like in the case of RDF, where you don't really know your data type a priori, it will often be the case that you will have regular data types. So, for example, the price of an item in a price list will be numeric, or will be a float, or will be an integer, and so on. So then, while your data in principle is typed at runtime and every consecutive value may be of a different type, you will very often get homogeneous vectors where all the items are of the same type. And when that is the case, you can do, say, efficient arithmetic by using a type-specific operation even when your data is not a priori typed at schema time. Also, dynamic adjustment of vector size is possible, so you can vectors give you locality, and if you see you're not getting enough locality, if your vector was 100 times larger, then and your data points were spread at random, then you would have 100 times denser spread of data access, and the more locality you have, the more speed you have. So this can make a big difference. Let's say 30% in some cases. Okay. Okay. So next, let's talk about graph functions and RDF. So pretty much all RDF stores do inference by materialization. Now we have taken a departure from this because the inference that is most often done is about hierarchies and so subtype, subproperty, and the like, and these are very easy to do also at runtime. And if you do them at runtime, you can turn on and off your inference, your ontologies, and you don't have to materialize. And if you don't materialize, you don't use space. And if you don't use space, you'll have more data in memory, and that is important because as soon as you go to disk, everything stops. So okay, so there for the graph side, there are some operations, let's say recursive traversals, finding a shortest path between two places. Of course, there is the semantics of the Sparkle property paths, but we have more because we have extensions whereby one can return the steps on the path, one can return cost associated to steps on a path, and so forth. And of course, this is all available in Sparkle as well as in SQL. Okay, so then we have also support for all same as and inferencing that if two items share a same inverse functional property in RDF, so you have like two items which have the same primary key value. To say it relationally, then the engine will infer that they are the same item. Okay, so we have special query operators that will do that. Okay, so we believe that the right solution for inferencing is doing things as late as possible, but then not every time. So you have to memorize them and then recycle intermediate results, especially when you're talking about expansion of same as. Okay, and that's the direction in which we'll be going. Okay, so we take the next one. Okay, query optimization. Of course, query optimization, especially if you're doing analytics, is absolutely necessary. Without the right query plan, it does not matter how good your engine is. And so the traditional SQL statistics do not help because it's one big table that you join to itself. Pretty much all RDF stores implements are based on a quad table where you have a 4-column table, a subject, predicate, object, graph, and then you have diverse ways of indexing this table, and then this table gets joined to itself over and over and over. Okay, so cardinality estimation. So if I have this sequence of predicates in the query plan, how many rows will match? And okay, so this is the very basis. Without some sort of guess concerning this, you cannot do join ordering, and you cannot do join type selection, and you can basically do no query optimization, whatever. So okay, what Virtuoso does is sampling. So given the query and given any literals in the query, whether it's predicate or object or subject, it will check how many data items there are actually that match this. And then for each predicate, you will, let's say you have a single valued predicate like the birth date of a person. You will know that if each person has a birth date, and only one of them, or you might know that half the people have a birthday and only one birthday and half don't have, and so on. So you do have cardinalities, predicate by predicate, so the fan out. You will also, okay, so if you have a multi-valued property, like let's say part of or many-to-many, like in a social network where you have 12 nodes, then you will know how many ways this branch is out on the average, so how many people does an average person know. And this allows you to do optimization without, say, a priori pre-computed statistics. However, when you get more complex queries that have conditions on multiple predicates, there is a so-called independence assumption that will get you wrong results, because sometimes you may have conditions that are both commonly true, but they don't occur together. So you have correlations in your data. And in order to do query optimization in the presence of correlations in the data, it is in fact necessary to sample through joins. So you execute your candidate query plan on a fraction of the data, and then you see what cardinalities, what fanouts you get, and this will allow you to have a more precise estimate. And of course, the more precise your estimate, the more confidence you have in the cost model, the more possible it will become to do tricks which have a non-zero setup cost. So, for example, hash join. Okay, relational databases, certainly for analytics, do hash join all the time. Well, in the case of RDF, hash join is not so commonly used because if you do a hash join, you have a certain setup cost, and you must have confidence in your model. Otherwise, if you guess wrong, the hash join might ruin your query plan. So we have some ongoing work for further optimizing this, and this is all going to become available in the open source cut as and when the work proceeds. Furthermore, of course, another reason to do sampling is if you have inference with same-as or IFPs. There is no static way of figuring out anything concerning them, so you have to actually run on a sample of the data to see whether these affect the cardinality of your data set. So sampling through joins is a direction definitely to do. Okay, so let's talk about clustering. Next slide. So in the Elastic cluster, we have tables, and tables have partitioning columns. So that's classical of any scale-out database will have this sort of technique. And so you have a table, and you have rows in the table, and one or more columns of the table decide by their values which partition the row goes to. And then these partitions are then divided among physical machines. Okay, so what we do specifically is that the database is divided in so many physical slices. Initially, you'll have maybe one physical slice per core or per core thread per process. So this means that, okay, if you have a single query and you have one thread in each slice, you will have full platform utilization even with a single query. Oftentimes, of course, if you do analytics, you do not have so many concurrent users, but a user will expect to have full platform utilization, so parallelism, to exploit all the capacity. So that's why it makes sense to put as many slices or maybe double the count of the CPU cores. Okay, now when the cluster grows, when the data grows, you can split these slices. And the more distinct slices you have, the more possibilities you have of dividing this work equally among a variable number of machines. So you can actually move a partition of the data from one server to another. This is what key value stores typically do. It is, of course, easier to do that with a key value store than with a full function transactional database like Virtuoso. But we have accomplished to do this, so you could say we offer some of the flexibility that's traditionally only been found with key value stores, with a full schema, with structured query, with everything you have come to expect from a database. Okay, so let's move ahead. So optimizing for cluster. So I also already talked about vector execution. This means that you always, if you have in your query multiple values or multiple sets of bindings, multiple rows of data you are operating on, you always operate on them together. Of course, in a cluster, this is especially important because you must be sending messages across processes, and even if the processes were on the same box, the overhead of sending a message, especially the overhead of blocking to wait for a reply, is prohibitively high. So therefore, to get any benefit from any sort of scale out or parallelism, whatever, you have to be as asynchronous as possible. So never block and have always lots of operations in flight, and as little central coordination as possible. So if you have a scatter-gather pattern, like one server in a cluster coordinates the query execution, and then it sends out tasks to other ones and blocks to wait for their reply, you can get maybe 400% CPU utilization, no matter how many CPUs you have. But if you have a model where everybody talks to everybody else and can coordinate their own fragment of the query independently of everybody else, then you get full platform utilization. This is very important, and we have made significant improvements in this over Virtuoso 6. So now subqueries, joins, aggregations, of course, will all have distributed coordination, and you can have arbitrary, even recursive function calls between threads, between nodes in a cluster while evaluating a query. So full platform utilization, that is very important. Of course, then you can distribute your clients among many nodes in a cluster. So every node is every server process is provides the same service as every other one. So there's no dedicated roles there. The only things that are localized are things like distributed deadlock detection, stuff like that, which plays a very small role in these typically read-dominated workloads. One recent experiment we did with a cluster was running a graph clustering algorithm where you look for communities in a graph. In this case, we did it with dbpedia, and this is a thing that for running on a large graph, you wish to distribute this, and you wish to have a message traffic then going from all places to all other places, and you have lots of updates. So this is not a typical SQL analytics query. This is a very update-intensive workload, and we could do this on a database. So having all the scalability and manageability features you expect from one. So that's a recent thing. There's a paper possibly going to be published about that, and will be on the net in some weeks. Okay, so if you have a single box and you run a cluster setup on that, which is always possible, you don't hit any major latency. Actually, it can be a little bit faster or a little bit slower than a single server, depending on how good a match your query is to the parallelization. When you go from one box to two boxes, let's say with a BI type workload, you get 1.8 times the throughput, which is very good. A cluster is a different game from a single server, so near linear scalability as you add nodes is not something you can take for granted. But certainly with big queries, we do a good job of that. Also, if you got small queries, same thing, because then you will have more latency, but you'll have more throughput, and you can divide all your client connections over a large number of processes. So in this way, you get your net throughput will increase, even though your latency might be a little bit higher than with a single server, because there's message passing going on, and this always takes time, even if you got a fast network. Okay, so there's some deployments of the cluster. Let's say the LOD cache. which is some 55 billion triples. It's running on 2 boxes with 384 gig each, only 4 terabytes SSD. So we, and this includes all literals, everything. So again, we could not do this if we did not have the amazing space efficiency we get from the column store technology. Okay, so we recently did, next slide, Berlin. So we, as I said before, CWI, so the folks behind MonetDB and later Vectorwise, have been working with us on in LOD2, and of course we have received a lot of, we have been influenced by the pioneering work that these groups have done, and a lot of it has now been adapted into an RDF use case. So another thing we did at CWI is running on the Silence cluster, which is in this case 8 boxes with 256 gig each, and we did some high-end runs of the Berlin Sparkle benchmark. So you can run with 150 billion triples on a cluster, and you get good platform utilization even with a single query stream. We often get, let's say, 220 threads out of 256 max threads going at the same time. So we can really take advantage of a big platform, even with a single query stream. So the query times, we do several queries per hour with this very large data set. Each query touches tens of billions of triples. Some of these triples are touched many times. And that's big aggregations over these. And we can run these in pretty much interactive time, so queries will terminate in a matter of minutes or so. So this is, and this is an ongoing thing, so these numbers will be updated from time to time. There's quite a bit of data on the web, and we will also be announcing new figures and updates on the OpenLink blogs. So here, for the first time, we also did the BI mix, or primarily did the BI mix, which is business intelligence, so complicated aggregations over the BSBM dataset. Okay, so we're coming to our future work. So there are some further gains to be had in the domain of query optimization. So never more bad plans. Of course, bad query plan is the #1 cause of any complaints that have to do with performance. So if we can radically decrease the accuracy of cost predictions in query optimization, then it means a lot more predictability for the user in terms of response times and throughput, especially when you do analytics. And of course, you know, if you present an online endpoint, you want to have predictability, and you certainly don't want to be paying extra for bad query plans. So query optimization is very important and will continue to get attention. Ultimately, we aim at doing a very good job at TPCH and TPCDS, which are TPCH is a long-time dominant relational business intelligence benchmark. And of course, we execute that in SQL as well as in RDF. And I think we are the only RDF store that actually can run these queries. When you translate the SQL to Sparkle, you get very complex queries with lots of structures, nested subqueries, big group bys, and we can run this in Sparkle. Now then, the ever-present challenge is driving down the cost differential so that we can get as close as possible to the SQL performance while continuing to drive up the SQL performance. So this is a continued journey of database optimizations, more efficient hash join implementation, more accurate cost model, better choices in function shipping across a cluster, so who does what so as to take advantage of all resources, and so on. So that is our roadmap, and that's where we are, and that's where these are the things on which we will continue to work, and these may best be followed in near real time with the Virtuoso open source cut, which is found on GitHub. So to conclude, it cannot be overstretched that this column store technology is a major win for RDF, certainly makes RDF viable in places where it previously was not, and of course makes Virtuoso also an option for SQL workloads that have to do with analytics. So this concludes the talk, so I would be ready for questions.
Thank you very, very much, Ori. That was a really great insight into Virtuoso 7. And as you see, you get all the links here, and we will publish the slides. Then you can follow all this information also in more detail on the websites that are provided. And also thank you for your introduction about OpenLink software. We have plenty of questions coming in. And maybe we start with a not so technical, and then we go in more and more into detail. So the first one is an interesting one here. Maybe you would like to react on it. It says, please, will you help the BBC serve out their linked data? What is your reaction on that?
Well, we could, of course, but OnTheText is BBC's current RDF vendor.
That's
so, so can we do something in that space? Of course we can. I mean, we were bidding against OnTheText for that, but OnTheText is the current vendor. So outside of this, of course, you know, BBC data, insofar it is open data, may be cached in our diverse services. But then these are not operated by the BBC, and we do not make any representations about the timeliness or accuracy of that data. But of course, I mean, we will be caching open data as the opportunity presents itself.
All right, thank you very much.
I would also like to say we did host some data sets for the BBC in the past, their music and program data sets. We hosted a service for them, and that is available as an EC2 AMI, where you can download and instantiate that data set in its entirety. And any data sets that they do publish, we ourselves will publish those data sets and make them available if they're part of the LOD cloud, which I believe
You're right.
they intend to do as well.
Absolutely. Yeah, thank you very much.
Okay, it can be said, however, that we are working together also with OnTheText and via this connection also indirectly with the BBC in defining RDF benchmarks. There is this FP7 project called LDBC, Linked Data Benchmark Council, and it has the Free University of Amsterdam, so Peter Bonch, the king of the column store, one of the pioneers of column-wise technology, MonetDB and VectorWise, who's the scientific director of these. Then there's Technical University of Munich with other people from Hyper, Thomas Neumann, very, very good database people. So it's a brilliant consortium, and we are working on making benchmarks, and much more relevant and interesting benchmarks than, let's say, BSBM.
Yeah, I think that's very interesting for the audience. It's the LDBC, the Linked Data Benchmark Council, and I think you find it very easily on the internet, Googling for it, but we can put it into the slides also.
So BBC is indirectly related to that, and they're supplying some use case data and so on. So we will have, let's say, BBC-oriented database comparisons and benchmarks in a future that's not very remote.
Absolutely, that's great. Let's go a little bit more into detail of Virtuoso 7. I have two questions regarding Virtuoso 7 open source. The one is saying, when will Virtuoso open source number 7 edition will be available? And the other one says, I have built Virtuoso open source from GitHub and experimented with it. At some point in time, will Virtuoso open source be updated to Virtuoso 7 technologies? So meant column store.
It is. It's available right now on GitHub. Virtuoso Development 7 is the branch tag, and it has all the column store stuff is there. So there is no scale out, but there is geospatial indexing, and there is column store and vector execution. There, pretty much everything except for cluster in what I was talking about is there.
Okay. Thank you very much. Then there is a good question about the column store. Is the column store based on the previous SQL engine used in Virtuoso 6, or is it based in any new NoSQL engine?
It is a substantial rewrite of the SQL engine in Virtuoso 6. So the rewrite is not limited to column store because we have vectored execution, and vectored execution is also for the row-wise representation. So you can mix and match row-wise and column-wise representation, especially when you do SQL in Virtuoso. And okay, so if you have lots of random updates, row-wise is usually better. If you have big queries column-wise, or even big bulk load column-wise is better. And you can mix and match them, and with both cases you get vectored execution. So vectored execution is goes through the whole architecture and is a major rewrite of this. The for row-wise databases, a Virtuoso 7 can read a Virtuoso 6 database file, so the data layout is same, but the internal execution engine is different. So it is a full-blown SQL engine with both rows and columns and vectored execution and query parallelization, much better than with Virtuoso 6. And then okay, it has certain specific RDF adaptations like runtime data typing and so on that a normal SQL engine would not have. Also query operators for inference and stuff like that again are RDF specific. But it's basically it's SQL plus all the RDF adaptations that are needed in order to do RDF efficiently.
All right, thank you very much. We're going into the next one. That is, maybe you can answer in a few sentences. You mentioned, you mentioned the concept of schema last, and there's a question. I don't properly understand this concept of schema last.
Well, okay. When it's schema first is when you have your schema. You model your application domain, let's say entity relationship model, and then you make a SQL schema from that. And then if your schema changes, then you must migrate your data, and if your modeling changes, you must denormalize, denormalize, do all these things, and this is the world of schema first. So your schema determines what data can be entered into the system. Schema last is the other way around. Like with RDF, you can say anything, whatever you want to say about any object without being restricted by schema. So this means that the cost of having some data that has, let's say, a different set of properties, a different set of relationships than some data you previously had can be accommodated without making a once and for all sweeping change that affects the whole data model of your database. So you can have, let's say, one-of-a-kind entities with schema last, whereas you would have to, in order to accommodate a single entity that was different, somehow had different properties, for example, different annotations, you would have to modify your whole global schema. And so key value stores have been traditionally used when you want a flexible schema. Of course, you can have a table in a relational database that has keys and values, but then it's difficult to query in SQL. So generally, the industry is pretty much all over the place is reinventing schema last, reinventing the triple, if you wish, under many different guises, because the need is pretty universal. Your data, especially when you integrate things, your data model will change frequently.
Absolutely. I think that was a very good explanation. Thank you very much. Now there's something about Elastic Cloud. So it says, does Virtuoso Elastic Cloud integrate with hosting a third party such as Amazon? E.g., are there standard options from normal EC hosts to get appropriate large SSDs?
Well, you can certainly deploy, and we have users who do deploy Virtuoso on the cloud, and also Virtuoso scale-out configurations. So this is something that's being done now with Virtuoso 6, and now can also be done with Virtuoso 7. The difference between 6 and 7 is that when you resize your cluster, you have much more fine-grained control over data placement, and then you can resize your cluster without reloading data with Virtuoso 7. So much better manageability. There can be some automation, let's say, for deploying a Virtuoso cluster of a given size on EC2. And this is something that is not presently automated, so you have to commission your instances on EC2, and then you have to set things up there and install software. But this is a task that could actually be automated, and maybe automated in the future, so as to provide, let's say, a shrink-wrapped type of cluster deployment on the cloud. This is, of course, a very timely topic.
Okay. Next one is there anything not backward compatible with Virtuoso number 6 in version 6?
Applications will run and queries will run. Databases can be read, and then there are some, let's say, full text indices might have to be rebuilt and so on. And then you can update a 6 database with a 7, and then in some cases you can even go back to 6, but it's not something that we would recommend doing. Certainly 6-based applications, stored procedures, queries, all of that continues to run. Of course, once you use column store features, these databases will no longer be compatible with Virtuoso 6.
Yeah, that's clear.
But in the forward direction, of course, it will be. You can go from 6 to 7.
Okay.
Without any major hassle.
Yep. Full update, and everything works fine. Okay, another one. We got many, so I hope you get lots of good answers, but I'm sure you have. So we have here RDF store versus inference engine. What are the features and limitations of Virtuoso as a inference engine compared to ALIM or others?
Well, we do there's a common core set of features that we meet in application after application. And these are, okay, RDFS++, some people call it RDF's prime, whatever. And the features in question that we do support are, okay, subclass, subproperty, transitive, same as identity via sharing of IFP values. So if two have the same email address, for example, then they could be assumed to be the same if the inference semantic so declares. And then there's equivalent class, equivalent property, same as I already mentioned. So that's the common core set of inference things that we find time after time as being used, and that's what we support. But this does not exactly match any of the OWL profiles, but it's, let's say, a common core set, and that's what we do. Mm-hmm. And we do this at runtime, so without materialization. So then this means that you can run the same query with and without inference, and you don't have to, let's say, repopulate your database or do any forward closure computation.
All right, sounds good. So the next one is about Gina. What Gina ARQ version is compatible with Virtuoso 7?
Well, we don't do ARQ. We do have the Jena APIs, so Jena applications will work. The Sparkle dialect is, of course, the core set of features is the same, but there might be some differences of dialect and differences of built-in functions and some extensions we have that Jena doesn't have. So ARQ itself, the Jena query engine, is not part of Virtuoso, but we are at the API level, we are compatible.
Mm-hmm. Okay. And I think I pick a last one. We have a few more, but I think time is over because we have just crossed the hour of our webinar. So there's another question about cluster. So it says, when running on cluster mode in Virtuoso 7, if a single node is down, are the remain nodes available for writes, or won't they accept writes as in version number 6?
Right. Okay. So if you have every partition in a single copy, and then one of your nodes is down, then of course this partition will no longer be available. So there's nothing you can do about that. You can have, it's a feature that we are working on testing and productizing. You can have partitions in duplicate, and if you have every partition in multiple copies, then of course one node going down will not take anything offline. But this is something that we are not doing in production, but we have capabilities in this direction, so fault tolerance. But it's a little bit further down the road.
All right. Okay. I think, yeah, first of all, I would like to thank you, Ori, and you for that great webinar on Virtuoso 7. I think we also should thank Peter Bons from CWI in the Netherlands, because I think Virtuoso 7 is also a success story of the LOD2 project and the cooperation between OpenLink Software and the Center of Wiskunde.
Yeah, we have very significant input from them, and they have been their work has been a great inspiration for Virtuoso.
Absolutely, yes. So thanks, Peter, here. By the way, another success story, just to let you know, is that our semantic web company Pulp for the product suite, the Thesaurus Manager, is now already integrated with Virtuoso 7, and we will have a webinar together with OpenLink Software in June, and we will let you know. And a few more announcements is the LOD2 webinar series in May. We'll have colleagues from University of Leipzig. We will talk about visualization tools on top of linked open data and linked data, namely CubeVis, SemMap, and Paola. And then before the summer break, I hope we can have a webinar on the first third-party component that is in the LOD2 stack that is called Apache Stanball. And I think we have these announcements in the slides. So if we can go. Yes, exactly. Thank you very much. Okay, there's one last announcement. We would like to ask you to help us in the LOD2 project. We have set up a LOD2 stack usability survey 2013. So when you have been working with a stack, when you're playing around, or you're planning to do so, or you do it maybe tomorrow, then please go to the URL we're giving here in the slides and support our usability survey.
Hope you enjoyed staying with us. If you need more detailed information, visit us at www.lod2.eu and let us know how we can improve to meet your expectations. Don't forget to register for our next webinar. Have a great day and don't forget.